So in this video, we are going to discuss how to do the resource sharing in the distributed environment with the help of the Kafka. But I will divide this video into three parts. In the first section, I will explain what is the problem statement for you better answering and the discussions on that. Second part, I will explain a little bit basic idea about the Kafka, their topic, partition, consumer group. And the third part, we are going to solve this problem. So the first part of this video, so what is the problem statement? So suppose in your database, you have tasks, 1000 tasks with all the details, right? And the task number is there from 1 to 1000. Or this database could have the multiple tasks, but at a time we are fetching the 1000 tasks to compute it, right? And you have to finish these tasks in 1 hour time. So what you will do, you will simply make one VM or virtual node and you will connect and give all the tasks will do that. But you observe this one system is taking the 4 hours time. But you have to finish these tasks in 1 hour, right? So what you will do, you will add the, suppose this is the one worker node, so you add the continuous 4 worker node, right? So it will take 1 hour time, it will take 1 hour time, it will take 1 hour time, it will take the 1 hour time, and within the hour time you can fetch it. But problem is that when you up and running all the machines, 4 machines, we don't know means from which row number to which row number they will pick up, right? They might be pick up from 1 to 500, they might be pick up from 120 to 600, right? We don't know. So you have to give the information to the other worker node that he should pick up in the sequence or in the some category wise. So what you will do, you will maintain one config file, and whether you say W1 should pick up from 0 to 250, W2 should pick up from 250 to 500. Same way W2, W3, right? 751 to 1000. So these guys will take from 1 to 250. This will take from 250 to 1 to the 500, and at last 750 to the 1000, right? And you can say, and this is called your distributed environment, right? The moment you add more than one system to perform the same task, the larger task, that environment becomes the distributed environment, because you are going to distribute your task among more than one worker node, right? So far so good, but thing is that you have to maintain, you have to do the hard code, right? So for this worker node, you should have the hard code. So when you add the new system, for the particular system, you have to do the hard code. This is the one problem, right? And so one problem is that you are going to maintain the config of the hard code. Now, suppose one system down, then you have only 3 systems. So again, you have to change the number, right? Because you have the 3 systems, you have the 1000 tasks. So again, you have to divide into 3 machines, right? So 400 to 6, and here 677 to the 1000, right? So you have to do the rebalancing every time, right? Whenever system is going to up, down and up. And suppose if you add the one more system, right? In the same case, you have to again rebalancing the config things. This is the one second problem. Third problem, that you have to always monitor if any system is going down or not. If it is going to down, you have to do either you have to do the rebalancing, or you have to add the new machine immediate, right? All those things you have to do that, right? So these are the problems are there, because in the distributed environment, system might be up and down, so you should take care automatically. But here, every time you have to change the config file and you have to do the rebalancing, right? So this is the problem statement. In the second part of this video, let me explain the Kafka in short period of time. So you will have the refresh your or the agenda or the concept. Okay, now switch over. Forget about this part. Just switch over your mind to understand the Kafka. What is the Kafka actually? So suppose another use case. You have the mini data producer component, and you have the many data consumer component, right? So these are the component, microservices or anything. They want to talk to each other, right? So these are the things. But it is very complex thing, right? Tomorrow if you add some more component, again this communication would be there. So that was the solution for this. What we did, we use the messaging system. This is called the messaging system, or you can say the distributed messaging system. The moment you say distributed messaging system, means single point of failure is not possible here, almost not possible here. And then whatever this producer will communicate this messaging system, and this consumer will take the data from there, and here it is the decoupling. There is no connection directly between the producer and the consumer, right? They can do the work independently, their own pace, right? If this system is very fast, they will send the data with their speed, and this data will store here. If consumer is not very fast, they will pick up the data as per their computational speed, and everything is stored here, so no problem. Anytime they can come, they can consumer come and take the data, right? And for that, we have the concept of the topic, right? You might heard that you have the concept of the topic. And these guys, or the producer, will write their information into the topic, and all the consumer will read the data from the topic, right? But if you think here, again some problem here, if you have the one topic and there are the many producer who are putting their data, so then you will not get the good throughput, right? Because when we start writing they have to wait, and the second will come they have to wait. So it is the serial operations. To make this system as the parallelism or high throughput, if you want to achieve, then you should come up with some different mechanism. And so what we have done in that case, we divided our topic internally. This is the topic, but internally we will have the many partitions. Partition P0, P1, P2, P3. So now if you have the producer, many producer, they can send the data, but this producer does not aware anything about how many producer, how many partitions. That producer will only know that you have to hit to the topic and give the data. But internally, if you have the many partition, that we can achieve the parallelism, and the producer will start giving the data without waiting for each other. So we can achieve the parallelism and the throughput at producer side, right? Now think is that if you're sending the data with the so much speed with the topic, then consumer side also we should achieve the parallelism, right? Otherwise, what happen? Your throughput, you complete end-to-end throughput will not high, right? So to make the parallelism and the high throughput at the consumer side, so you have to also do something in the consumer side, right? So suppose now this is the consumer, we have the concept consumer group. So as we create the many partition, same kind of things, we can add the many local node, many virtual node in one consumer group. And then they will start taking the data from here. So here we can achieve the parallelism, here also we can achieve the parallelism, right? So if you have the huge tasks, we create the many more partitions and you can add the many more consumers, right? So now my focus is on this, the partition and the consumer. So this is the partition 1, 0, 2, 3, and here this is the consumer 0, consumer 1, consumer 2, consumer 3, but within the same consumer group, right? Let me explain this part in more detail. Okay, so okay, let me explain here on. So let me suppose if you have the four partition, If you have the four partition in the topic and in the consumer side, if this is your consumer group, right? So if you have only one consumer in the consumer group, they so all the partition data will go to this consumer because we have only one consumer, right? Keep in mind, any point of time, partition will any partition never ever send data to more than one consumer in one consumer group. I will explain you in detail. So now we have the four partition, we have the one consumer, they will give all the data to the consumer. Now I add one more consumer. The moment earlier all the partition 0 to 3 data was coming in this consumer. The moment you add the one more machine in this consumer, then what happen? Your data will partition data will do two data will go here, two partition data and two partition data will go this consumer. And that is called the rebalancing. Rebalancing by the Kafka, and they will change this number to 0 and 1 will come on the consumer 0 and 2 and 3 will come in the consumer 1. Now suppose you add one more consumer 2. Then again rebalancing will happen. So how the rebalancing will happen? This will go here, this will go here, this might be go here or this also to go here. We don't know. That could be anything. So as per this diagram, then these guys will get only one partition 0 to 0. These guys will get 1 and 2 and this will get the 3. Right? So now I am going to add one more consumer in the consumer group. Then it is easy. Again do the rebalancing. Right? So this time this will give this two data and here data, right? So everything will change 1 to 1, 2 to 2, means from 3 to 3, actually means 1 to 1 mapping, right? So this is the way. Now, important thing, very important thing, if you add one more consumer in the consumer group, what will happen? This will be sitting idle, he will not receive the data because all the partitions already occupied with the consumer, and as per this the definition, none of the partition will give the data to more than one consumer. So this system will, this consumer will be ideal. So your number of consumer in consumer group always less than or equal number of partitions. Right? Sorry, partition. So these two things is very important. This part and this part. Never a single partition will connect to the more than one consumer in one consumer group, and number of consumers should be in the consumer group less than or equal to the partition for the better performance. If you add the more consumer in the consumer group, there is no benefit. That system is sitting ideal, right? And on this logic, so now if you see here, rebalancing is done by the Kafka, so your problem will solve. No need to put the config because this range is be taken care by this one automatically that I will show you. And third thing, if any machine, any consumer group is getting down, that Kafka will understand that system is getting down and they will take care. So you no need to do the monitoring part also, right? Now I'm telling the one out of box thing that is not required here, but just for your understanding. So suppose you have the four partitions in a topic, and here is the one consumer group one, and another consumer group, and here is the two, here is the two. So what happened? Suppose this is not there, so two will connect this one, and two will connect this one, and the same thing here it is there. So, as per this definition, one partition can only give the data to one consumer within the one consumer group. So he can maintain all the offset ordering. But you have the two consumer group who is subscribes this topic, then this partition will give the data another consumer group, another consumer in another consumer group. But within one consumer group, it is bonded to give the data to only one consumer, right? If everything you understand, let me connect the both concepts, this problem statement and this one. So now, after getting the problem statement and the Kafka concept, let me connect both parts. So how many tasks you have to distribute? 1,000 tasks. So you create the partition, 1,000 partitions. You create one topic, take any topic name and create the 1,000 partitions. So here is the 1,000 partitions in one topic. So we are not going to receive any data in the Kafka. Only you are taking the advantage of this concept to solve the problem. So create the 1,000 topics. Topic is created. Now you create one consumer group. Okay. Your worker node is there, W1. So main problem is that you want to assign this number, right? As per the number of worker node. So what happens the moment you will subscribe this the consumer group by this worker node, it will act as your consumer. I will show in the code, and here is the topic, 1,000 topic. Automatically Kafka will assign all the topic partition to this worker node. So you got this number, so you got this range, and from this range, if you want to connect a database, whatever you want to do, you can do that. It was the issue, right? How you can give this number. The moment you create the another worker node, I have already explained you the moment you add another worker node in the consumer group, what they will do? They will do the rebalancing. Right? So what they will do now? It will give the half partition to the worker node, half partition to the worker node second. So 500 partition will come here 0 to 9, and this range is the 500 to 999. Because this is the nature of the Kafka. Kafka is distributed system. They do the rebalancing every time when you add the consumer in the consumer group, and you are going to take the advantage of that, right? Again, if you want to W3, W4, so it will change the number from 0 to 249, 252, 500, 501 to add just simple I'm writing here, and the 751 to the 999, right? Because what happens when you adding, the moment you add or remove any worker node or consumer in consumer group, they will pass one callback method. and in this callback method you will notify that what is your range. So if suppose now this two system is getting down, W3, W4, immediately these two guys will get the notify with this callback method, and they will get the new index, new range. From here to they have to do that. So the solution is that if you add this worker node, just what you have to do, instead of doing all those things, just subscribe this worker node as to the consumer group and receive the range. So it will subscribe this consumer will give group, it will give the range, right? Again, you connect this one, he will give the range. The moment he is giving the range, he will hit the callback method. He will also come to know that one new worker node has been added, and that number would be changed. So once I will show you everything in the code, it might be better understanding for you. Thank you.
To do first, you have to start the Kafka, then you have to create the topic, then you can do that, right? So let me, yeah. And if you see, I am the Kafka. If you go the bin folder, so I have all the libraries to start that, right? So first you have to start the zookeeper. So zookeeper server start, and you have to pass the config, right? So you go my the zookeeper video, I have explained everything. So here you can, so it will start your zookeeper, right? If you can see, the zookeeper is started, right? Okay, so it is started 2181. Okay, no problem. Now you have to start the Kafka. So you again here go to the bin, and then we do the Kafka, right? Kafka server as start, and you have to pass again config. Config is the server config, right? So it will start the Kafka, right? Now go and create some topic. So how to create the topic? In the code I have given the topic name sharing, right? This is my topic name. Create one topic sharing. Partition, how much partition should be there? Keep the partition 1000, right? So this is the command. So I given that Kafka topic, and topic name is the sharing, and then localhost, this your Kafka is running on the 9092, and give the partition number is the, how many partition you want, we want the 1000, right? Okay, they created, right? Now if you go and check this command, so it will show the one of the topic is the sharing is created, right? Everything fine, right? So now we have to start our the code, right? So just let me go through the code. So we are connecting to the Kafka 9092. Group ID means the consumer ID is the distributed, topic name is the sharing, right? So what you will do that in the basic setup will be setup means you need the create properties file, everything you have to do and all these things. So if you see, we are creating the UUID for the each worker node, because in the production system you will have the IP address to distinguish, right? But here in the one system you cannot have the multiple IP system. So I create the UUID, and it will assign this the consumer ID worker node, right? So if the worker node, or you can say, okay, this is worker ID. So this ID, what you're going to do that, this is the worker ID. So identify which has the which range number, right? And this is your callback method. As I was saying that you have to do the consumer rebalancing listener. So in this we have the two method on the partition revoke and the partition assign. So what you are doing, whenever you are assign rebalancing the partition, then this method will call, your method will call callback method. I have created a callback method, and you have to just pass the consumer ID, what consumer ID you are creating here, and you can just pass the ID, no need to do all those things because you are passing the same thing. Here it will be there, and the partition. So when this callback method is happen, it give the only the assigned partitions to the particular consumer. So if you have the two consumer, they will assign the first 500 to one consumer and second 500 to one consumer. So in this worker node, each worker they will get their partitions, range of the partitions. So in the callback method, nothing what you are doing here, we have all the assigned partition. So these partitions will come, if you print this partitions number, they can print in any random order, 1 to 9, again 8, something, right? So just to show you purpose that what is the range of the partitions, I have just make the main mix. So all the minimum should be come here, minimum number should come here, maximum number should come here, and so I can show you what is the range of those things. If you see, the gist of this code is only this, the callback method. So whenever this on partition assigns happen, whenever this new worker node attach or detach, this method will call, and this method will call, and your callback method will work, and then from the callback method you will have the assigned partition range, and then you can achieve the assigned partition range. That's it. And all the code I have already given in the GitHub. So if you go the GitHub Vinod Suman, and here go the zookeeper. So run the first worker node, right? So I'm just running this command right now. One worker node is running, so their range would be the 0 to 229, right? It is saying number of talks is for this worker node is the 1000 and your partition is the 0 to 9. So you have to pick up all the tasks. The moment you run the another worker node, right? Now you can see, watch here, this number of talks would be changed for both. Then we have the 500 each. See, it becomes the 500, it also the 500, then a range 0 to 5499, and this guy is to range this one, right? So now add the 3 worker node. So just same up the worker node. So now you can just keep watch on this number. It was 500, 500, now it becomes the 300, 340, and this guy is also 300. So now you can see the range. They are going to change the range. Now do one thing, you delete the first one, Control C. Now you see this both worker node, we have the number of tasks change. It was the 333 because it was the 3 machine, now we have the only 2 machine. So they have added, distributed according to number of the worker available, right? So this is how it is working, that. So you can achieve any kind of the distribution range based problems with the help of the Kafka. Yeah, that's it for this video. Hope you will like it video and try to subscribe this channel. Thank you very much.